this webinar for the Potato Congress. Good morning, everybody. I will start the seminar, the webinar for the World Potato Congress.
Marcelo, are you having some technical issues?
No, I just advancing. I started at 11, as it was planned, and I started advancing slowly the slides.
Okay,
You want me to go back? I go back.
just wanted to make sure there wasn't any issues because we couldn't hear you talk about the slides.
No, I didn't talk because they were
Okay,
the slides
sorry.
were self-explaining.
Okay, all right, thank you, so sorry.
Should I continue like this?
Absolutely, sorry about that interruption, thank you.
Okay, okay. So this is the title of my webinar today, Autotrophic Hydroponic System, SAH for the name in Spanish, for sweet potato production. I included one other author, which is Susana Rigato from Satecno. But I will do the presentation and Susana may help me in some of the questions if there are any at the end of the webinar. So the SAH takes in consideration a wide range of factors. Normally, as you know, tissue culture focus mainly in the media chemical composition, the application of growth regulators or phytohormones, and sterilization techniques. But instead, SAH is characterized by all the above plus photosynthetic, the profiting from the photosynthetic capacity of the plants, the environmental conditions inside and outside the containers, and the growth improvement without phytohormones. Autotrophic stands, for those that don't remember, is the capacity of the plant to generate complex organic compounds using very simple substances based on carbon dioxide, generally using energy from light or inorganic chemical reactions. So from very simple organic compounds to go to the complex compounds that produce the growth of the complete plant. So in the past, we had Argentina was normally characterized by the economic crisis, which we are quite accustomed to them. So we decided to go further in trying to replace the traditional tissue culture into something else that might help, not depending on imported inputs or heavy cost of production. So SAH came out as a combination of traditional tissue culture, the profiting from the autotrophic growth, and some hydroponic ideas. SAH produces high quality plants, as you can see in the slide on the right side. Compare, that's a normal plant from SAH and a normal plant, a very good plant from tissue culture. It promotes rapid growth, uniform plants, and improved plant performance after transplants, mostly. Traditional tissue culture does not help for photosynthesis. The environment under the traditional tissue culture is characterized by high humidity inside the containers of different sizes even, constant air temperature, non-air movement, low CO2 during the light period, high ethylene concentrations, high concentration of salts, and sugar at root level. Also, low transpiration rates implies less water and nutrient absorption, and as a consequence, less growth. High respiration rates and a negative CO2 balance results in slow growth, as I said. Slow growth plus saccharose in the media favors contaminations, which is a quite common situation in most tissue culture labs. Instead, SAH promotes photosynthesis. A typical leaflet from a plantlet in SAH and a tissue culture, a very good tissue culture leaflet, which is based, as I said, on the autotrophic capacity of the plant. Increases the leaf growth and stomata functioning. Stomata, as you know, is very important in the air exchange on the leaf, at the leaf level. So it promotes the air exchange, it promotes the root system development, and increases water and nutrient uptakes. So SAH, as a summary, increases the production rate at the same time that keeps the high health standards under the lab conditions, under control conditions. One other advantage of SAH that can easily be adopted by growers. Tissue culture labs are normally expensive, it needs expensive equipment and chemicals. In many cases, chemicals of high grade, high expertise of the operators, non-flexibility to changes in the production. Normally, when you ask for plants to tissue culture labs, they have fixed dates for expanding the plants to the clients. Losses due to contaminations are quite frequent, and plant needs to be hardened before transplanting to greenhouses, or the advantages in case of SAH that you can transplant to the field. Instead, SAH labs are not sophisticated equipment required. This equipment is normally available in all countries. SAH labs can be set up at the farm, near greenhouses, any place close to the utilization of the plants. Plants can go directly to tunnels, greenhouses, or sometimes even to fields. We have been quite successful in taking the SAH directly to the field, skipping the greenhouse stage. Flexibility to speed up the production. You can produce any kind in any date, any quantity at any date. And SAH reduces contaminations. We normally don't have any contamination, and in cases that there's some contamination, it's very easy to control it. As I said, it can be used directly by small growers. That's a case of in a school in the northwest part of Argentina, or you can use it in large high-tech growers, which have sophisticated greenhouses or whatever they use to produce mini tubers. I'm going to put two slides now that compare the tissue culture with the SAH in terms of speed of production. Considering that you can start with maybe 100 initial in vitro plants in both situations, you know that in tissue culture you you cut plants every 20 days, more or less on a fixed schedule. Instead, with SAH, you can, in 20 days, you normally arrive from those initial 100 plants to about 900 plantlets. And that is that is the slowest part of the propagation part. So that's the continuation in tissue culture. In 40 days, you arrive to maybe 2,000 or more plants, instead 10 times more normally with SAH, and the same thing every 60 days, you arrive normally to 60,000 plants, starting with those 100 initial plants. At the end, in 90 days, you probably have the amount of plants that you needed to fill your greenhouse. And this data is based on many average production rates in different labs across the world. We have transferred more than 70 labs in different parts of the world. As you see, plantlets grow very fast. They can be cut several times, and it's an exponential production. In the next slide, I'm presenting the same data on a graphical way, comparing this SAH with in vitro in the days and the number of plants. So let's continue comparing both technologies. In infrastructure, tissue culture is normally quite complex and expensive. SAH is quite simple, more efficient use of the space than in tissue culture. In equipment, the laminar flow hoods, autoclaves, and media dispensers, and so on, are needed for tissue culture, Instead, all you need in SAH is a separated cutting area with tables and lamps, non-sophisticated at all. Materials, lab glassware, tissue culture media, growth regulators, test tubes, flasks, or specific tissue culture containers, which is a lot of glassware glassware in the normally present in a tissue culture lab. Instead, with SAH, we use plastic containers used in the households, commercial grade chemicals, and over-the-counter fertilizers, non-growth regulators, easy to find food containers. So it's quite inexpensive, and the material you can discard it easily. No need to reuse as you need to reuse glassware. With energy, compare energy in both situations, putting 100 to tissue culture, 30 to 10 instead for SAH. So it's a great reduction in energy needs. The growth room turnaround is about 20 to 30 days, and instead in SAH is 7 to 15 days. In salaries, also the same situation with energy, from 100 compared to tissue culture, 30 for SAH. You don't need hardening area for SAH. Instead, you need to harden tissue culture plants from 5 to 10 days, depending on the conditions. The greenhouse area is also more used efficiently in time and space, with 100 for the case of a tissue culture, you can reduce it to 20 less time in SAH. Plant loss is 5% or less in SAH and can be quite high in tissue culture, depending on the situations. Different contamination is often uncontrolled and it's not easy to control. Instead, with SAH, it's almost nil and easy to control. So SAH can be combined with aeroponics and hydroponics. So you have a picture there with the SAH plantlets in the growth room and transplanted to the greenhouse. This is a lab in Brazil with a high production of mini tubers in aeroponics. Also, as normally used in many places, SAH plants are transplanted to beds. This is a greenhouse on the left in Argentina, and the other one is also in Argentina in a different place. So you can see the quality of the plants growing in these beds coming from SAH. What's the history on this technology? In 1986, as I said, with the impossibility of importing inputs for tissue culture, the infrastructure in the institution was quite precarious. We couldn't increase the production of INTA in those days. From 1996 to 98, we did, Susana mostly did all the SAH development studies. And we call it at the beginning with a MAEH, which stands for the names of the inventors. 1998, first SAH technology was first transferred to a grower in the northern part of Argentina. In 2000, we gave a presentation in society in the Congress of ALAP in Cuba. In 2001, there was a great economic crisis in Argentina again, and we started with this ProPapa project, which originated and this technology mostly and funded the technology, funded the salaries mostly of the people involved in this technology. From 2002 to date, Argentina's potato pre-basic seed is based already 100% on SAH with 14 private growers labs. 2004, there was a first international technology transfer in Fontagro in South America with the participation of Chile, Bolivia, Colombia, and Venezuela. And that was given in Balcarce in Argentina. Also in 2004, there was an adaptation of the technology to kiwi and to ornamentals. In 2005, we transferred it to subsistence growers in the northwest part of Argentina through a Monsanto fund. In 2005 to date, as I mentioned, there are about 74 private and government companies from America, Africa, China, and Europe using this technology. In 2009, we gave with Fontagro another workshop, and we transferred it to 6 Central American countries in Panama, where it was held this workshop. In 2016, we made an agreement with IITA in Africa, and we established the technology for cassava, and this was funded by the Bill and Melinda Gates Foundation. In 2016, we transferred to Sichuan company, potato seed company in China, and recently we are working with Egypt and USA. That's more or less the progression of the history of SAH in different countries. So how we do the transfer? The philosophy is to that the responsibles of the development of this technology are the responsible people for doing the transfer. And that's why we sign confidentiality agreements. We don't want failures in the transfer of this technology. So we do direct training to companies. We visit them in their place, and we do the transfer in their in situ. We also organize visits to ongoing labs mostly in in Brazil, Argentina, Uruguay, as it's more convenient for the new recipient of the technology. We also can do the transfer through workshops, as I mentioned, these two in Latin America and the one in Africa. These workshops are agreed normally with public institutions. And the steps for doing the transfer are a contract for technology transfer and the confidentiality agreement, the counseling on the infrastructure. Many of the clients or people interested in the technology already have an infrastructure, and we work with them in adjusting or easing the infrastructure to adapt it to this technology. We counsel on the plant material to be acquired, staffing of the lab, and inputs acquisition. Most of it's quite nice to go together to the markets and get the products needed to the SAH technology. So we do this in situ training, as I explained. We also use Zoom or any other platform, WhatsApp, In the start, we give a starting kit, which allows them to produce a certain amount of plants, and then continue from there. And we also produce a manual that is given to the company. And then finally, we certify the lab and do the follow-up for all the time needed. So as I mentioned, we transfer to growers, turn on key and training in situ, and visit to previously transferred companies. These are growers in different parts of Argentina, and that's a picture of the manual given to them. This is in transfer for kiwi in Italy. This is the largest plantlet production in the world for kiwi. Also, we have done some transfers in grapes, peaches, and that's it. That's our males, and the name of the company based in Houston, Texas, under Susana Rigato's management. So now I'm open to questions. Well, there's one question here from Sumit, which is he's asking what is the type of media we use in SAH production? The media is normally I cannot give the details on the media, as I said. We have this confidentiality agreement with most of the companies, so that's one of the key issues in the. But the media, in general, I would say, is normally the media's used for hydroponic conditions in most plants. So there's another question from André Devaux. Hello, André. How to produce the healthy plantlets that you need to start SAH process? What I mentioned is that we counsel the clients, or just call them clients, that this on how to acquire healthy in vitro plants from legal labs, official labs that give the plantlets with the certification of health from the certification agents, the plant health agents. There's another question which is relative to the cost of mini tuber of SAH compared to tissue culture. Well, you need, Peter, that's from Peter Joyce. Hello, Peter. And that is very, very interesting that once you have the plants in the greenhouse, is the cost of growing the plants in the greenhouse, which is the same cost for in vitro or for SAH. But I keep in mind that you need much less time to reach to the mini tuber production, maybe 50 to 20 days less in growth in SAH compared to plants coming from in vitro. So finally the cost is less, it's much less. So that's the only. But you have to have your costs in the greenhouse adjusted just for the two situations, which is mostly the same. The inputs are the same. It's just growing plants in the greenhouse. I don't know if that's clear enough. So another question from Thomas. Let me see. Niederbauer. How can that technology be combined with what is promoted as rooted apical cuttings technology by SIP? Well, I'm not well acquainted with that technology. I don't know if it is combinable or not. The only thing I can mention is that once you start with SAH, we don't know any of the 74 labs that went back using tissue culture or other technologies. So that's the only thing I can say. That's Andre De Boy is also asking. So the initial plants are coming for tissue culture. Of course, that's a based of a very small amount of. Normally, we have the cases of labs buying thousands of tissue culture plants to produce the needed amount of plants in their greenhouse for the greenhouses. In the case of SAH, you need to buy a very small amount of plants. That's a great difference in the initial cost. There's one question here that is asking how many growing days will it take for plants to be ready for greenhouse? That depends on you, because once you get the number of plants needed, you go into the greenhouse. So that's and the size of the plant is the size that you are accustomed to transplant. So it's I gave an example of 90 days there, but it can be 90 days. Sometimes people do it with less amount of time. What is the difference between SAH and conventional cutting routing? As you see here, as I explained, SAH is done under control conditions in the lab. The lab conditions for cutting have the same health requirements of the in vitro. So it's that's for saving this exactly the same purpose of certifying pre-basic seed under most of the organisms of certification. So a pre-basic seed requires this health status, and that's the characteristic in SAH as well as in tissue culture. Well, there's one question considering how you combine SAH with aeroponics. We combine the growers combine the SAH with aeroponics in the greenhouse for producing the mini tubers. Instead of transplanting tissue culture plants, they transplant SAH plants and produce the aeroponics. That's very simple. There's one comment from Susana, which says that substrates can be different. Usually peat moss or vermiculite is the base for those substrates. And that's, as I mentioned, these substrates are normally buy under the local conditions. There's one question very interesting here that could this technology be combined with vertical farming facilities? I guess so, because the technology, this technology is to produce for producing the plantlets, and you can put those plantlets in vertical farming or greenhouses, or as I mentioned, into the field. So that's it's very easy to combine. David Ennis is asking if this technology is available in the United Kingdom or the Republic of Ireland. Not yet, but you're welcome to contact us to do it. We have discussed this in Scotland once, but we haven't arrived to do a transfer of technology in the United Kingdom. One comment from Susana in reference to the cuttings, which is that SAH is, as she mentions, is very different to cuttings, especially in the nutrient solutions, and the specific with the whole process. In the whole process is quite different too. You arrive to a normally very high number of plantlets produced in a very short time, as I show in the graphics. Let me see if there's any other question. Again, another question concerning vertical farming, which is similar to the other one. I answered that yes, the answer is yes. You can grow these plantlets anywhere. There's one question concerning the direct transplant to the field. We don't have good data, but and the growers that were doing this in the west desertic area in Argentina, they stopped producing potatoes, so there's no good data to collect from that. But from the 2 years that they were doing it, they were quite pleased with them, and they didn't even have a greenhouse, so they just got the plants directly to the field. But with no data, I'm sorry. we can design an experiment and doing it with you, James. Hello there, Dawi Ras from South Africa is asking if this conversion is correct, 27,000 plants from 900 plants in 20 days. Yes, it's correct. And you visit here, Dawi, so you know that it's working. You can come again. There's a comment from Susana again, that in the Patagonia, which is also a desertic area with drip irrigation, it was that was done for direct transplant in the field. Yeah. Well, if there are no more questions, I would like to thank you for your presence and your questions. Very interesting, and you have the data there to contact us whenever you like. And